So here in this problem, we have been provided with a condition that a plus b plus c sums up to pi radians. We need to show that sine squared a plus sine squared b plus sine squared c that equals to 2 times 1 plus the product of cosine a, cosine b and cosine c. Okay, so we'll start our proof from the left hand side. On the left hand side, we have sine squared a added to sine squared b added to sine squared c. Fine. Now, we know where we have sine squared a added to cosine squared a, that's always equals to 1, which means that sine squared a can be also expressed as 1 minus cosine squared a. This will become evident in a moment. So here what we are doing here is we are going to transform sine squared a to 1 minus cosine squared a added to sine squared b plus sine squared c. Now what we can do, using the same identity, we can also convert sine squared c to cosine function as 1 minus cosine squared c. So let's keep it aside for the time being. Now 1 added to 1, that gives us 2. Let us take care of the factor 2 on the right hand side. Now we're going to combine the second and the third term. So let's take negative as the common factor. So we have 2 minus cosine squared a minus sine squared b within parentheses, and then we have the fourth term, which is cosine squared c. Okay, now the reason why we wrote in this fashion, because there's a standard formula for cosine squared a minus sine squared b. Now let's note down that formula. Cosine squared a minus sine squared b. So this is the difference of a cosine and a sine function. This transforms into the product of two cosine functions given by cosine of a plus b multiplied to cosine of a minus b. We're going to use this transformation. So we now get 2 minus cosine of the angle a plus b multiplied to cosine of the angle a minus b. And then we have the term cosine squared c. Okay, now what we'll do, we're going to transform cosine of a plus b. So here we're going to use the fact that since a plus b plus c, that sums up to give us pi radians. So here a plus b can be also expressed as pi minus c. Now if we take the cosine function on both sides, we get cosine of a plus b, that is going to be equals to cosine of the angle pi minus c. Now what is cosine of pi minus c? So that's going to be negative cosine c. We are getting a negative value because pi minus c indicates we are in the second quadrant where the cosine function is negative. In other words, what we have shown here is that if a plus b plus c equals to pi radians, then we can express cosine of a plus b also as negative cosine c, and it would mean exactly the same thing. So here we now get 2 minus cosine of a plus b. So we're going to replace cosine of a plus b with negative cosine c. That gives us positive cosine of angle c multiplied to cosine of the angle a minus b minus cosine squared c. Now as we can see, if we consider the second and the third term, we can take cosine of c as the common factor. So we have 2 added to cosine of angle c. So this is now going to get multiplied to cosine of the angle a minus b minus cosine of the angle c. Fine. Now the next task, what we'll do, we will convert cosine of angle c to an angle that consists of a and b. Again, we use the facts. Since a plus b plus c equals to pi radians, so what we'll do, we'll keep c on the left hand side and transpose b and a to the right hand side, and we write it as pi minus a plus b. What we'll do, we're going to take the cosine function on both sides to get cosine of c equals to cosine of the angle pi minus a plus b. Okay, fine. Now what is cosine of pi minus some angle? So cosine of pi minus some angle gives us negative cosine of that particular angle, and our angle here is a plus b. Again, pi minus that angle lies in the second quadrant where cosine function is negative. In other words, we have shown here that cosine of c can be equivalent to negative cosine of a plus b if a plus b plus c equals to pi radians. So now what we get is 2 plus cosine of angle c multiplied to cosine of the angle a minus b. So negative cosine c becomes positive cosine of angle a plus b. So now what we will do is add the two cosine functions. by taking help of the formula. That means if we have cosine of some angle C added to cosine of another angle D, then the sum of the two cosine function is given by 2 times cosine of angle C plus D over 2 multiplied to cosine of angle C minus D over 2. Now, for simplicity, we'll consider A plus B to be equals to C and A minus B to be equals to D. And applying the formula, that's going to give us 2 plus cosine of angle C multiplied to the cosine of A minus B added to cosine of A plus B gives us 2 times cosine of angle. We'll get 2A over 2 multiplied to cosine of angle 2B over 2. And finally, we have 2 added to 2 times cosine of angle A times cosine of angle B times cosine of angle C. And this is exactly the expression on the right hand side. So we can verify that. So we needed to show that sine squared A plus sine squared B plus sine squared A equals 2 multiplied to 1 plus cosine A, cosine B and cosine C. Okay, thus what we have done here, thus we have successfully showed that the left hand side equals the right hand side. Hence proved.